Hello everyone, welcome to Grade Up. My name is Hemant Parihar and today we will be learning about the routing algorithms. That is, we will be learning about DVR, distance vector routing, and LSR, link state routing. In our previous lecture, we have learned about some protocols. So we learned about ARP, RARP, BOOTP, DHCP and ICMP. So you must remember them, okay? So let's start today. So what is difference between routing and flooding? So what is routing and flooding? Suppose this is the network we are having, like this and this. So my drawing is very bad. So and you wanted, this router wanted to send packet to this. So there are three ways: this one, this direct way, and these two. So one way, two way, three way. So in flooding, what we are going to do? In flooding, we are going to send the packet in all three directions. This is flood the packet to all the ways. But in routing, what we are going to do? We see which is having the less traffic, then we will send it, or which will have the least cost. So accordingly, we will send the packet. So this is what the basic difference between the routing and flooding. In routing, we are actually doing better because we are not sending the same packet. But in flooding, we are sending in all directions. So these are some point about flooding and routing. In routing, we make a table so that we can determine which have the less cost path. Okay. So that is what we are going to do. We are going to build a table, routing table, that is known. And for that we have two dynamic algorithm. One is DVR, distance vector routing. Another one is link state routing. We will see them shortly. And in flooding, there is no routing. You are not using your mind, you are just sending packet in all direction. So that is what it is, routing. Here reliability is low. Suppose you send it in one direction and this packet may get lost. So it will never gonna reach destination. But here reliability is high. How? If suppose this packet is lost, even there are two other way to reach this packet to this destination from A to D. And here there is no duplicate, but here duplicate packets are there. There is low traffic, that is good thing, and there are high traffic in flooding. We are not going to use the flooding because in routing there is very less traffic. Suppose if you are sending 1000 packet and there are many links, so how much there will be duplicate packet? There will be lots of duplicate packet in flooding, but in routing it will remain 1000. That is why we are going to use routing, and we will see the routing algorithm. So first one is distance vector routing. So this is the image. This is A, B, C and D. Now what we are going to do, every node is going to make this table, distance vector, and I tell you how it make it. Every node it is going to make it. D is going to make for itself, B is going to make C and B, and they are going to use the local knowledge. Local knowledge means, see, for this A, it means that A wanted to go to A. This table is for A and A wanted to go to A. What will be the cost? 0. And how it go? It is going through A. So for when A wanted to go itself, then there will be no cost, obviously. But this means that A wanted to go B. A wanted to go B, this B. And what will be the cost? When they are drawing this, what they will do? They will only going to use local knowledge. Local knowledge means the link you are connected. So it is directly connected. It can see that this link has a cost 2. So it can write here 2. Okay, this is written as here 2. And how you are going? Through B. You are going B through B. Okay. So that is what the meaning. You are going through which. This means you are going through which. From A you are taking which node to reach that destination. Suppose C. Now C is not connected, so A does not have any knowledge about it. A will be having only knowledge about those who are connected. So there is no knowledge about C. That is, we have written infinity and we can't, that the hope we should take for it, it is like this, no hope. No next, yani we should not take neither B neither D. It is like this. Okay. Now to reach D, how will be the cost? We will see whether it is connected. Yes, it is connected 1 and D. So this, for the first time we are going to do it like this, and it is very easy. You can draw it for this one and this one also. Now what is going to happen? At A, they exchange in the next round, they exchange the distance vector to their neighbor. So A will be changing its distance vector only this thing, not this. Okay, so this is distance vector. So distance vector will be exchanged by each other to its neighbor. So A will send its distance vector to B, to D and B, and A will also get from B and D. Okay, so every router exchange distance vector with neighbor only. Okay, C is not going to give the distance vector to A. There is no way. Okay, now what happened at A, we get the distance vector from B and D, and if you see at B, if you see here B will get from A, C and D. A, C and D here direct. That is why we get 3 distance vector at B. At A we get 2 distance vector. Now this is the distance. At A we are getting this distance vector B, and at D we get this distance vector. Now what A is going to do to make a new table, first A will write what is the distance between A to B, that is 2. A to B, from A to B distance is 2 and A to D is 1. Okay, now I will tell you how to compute this table again. So A wanted to go to A, so that for it is going to be 0. Okay, so ignore this for first entry. For second entry, when it want to go to B, it will reach A to B in 2, then add this 0, and okay, I tell you, A to B is 2 plus 0, what do we get? 2, and 1 plus 7, what do we get? 8. So which of them is minimum? 2. So we write 2 here. And how we are going? Through B. That is how we written. Now we want to reach to C. So if you see here, there is no direct path from C. How we will update it? So A to B distance, actually what it is happening, it is saying that whatever I have written down there, it means that first we are reaching to A to B, then B to C, and it means A to D, then D to C, and we are seeing which of them is minimum. We are including, to reach C, we are including a vertex, one vertex. Okay, and that is maybe B or D. We need to find, and how we need to take the minimum of these two. So A to B is 2, B to C is 3. So total will be 5 here, and A to D is 1, and D to C is 11. This one will be D to C, corresponding to D to C, that is 11. So it is 12. Which one of them is minimum? You write it here. 5 is minimum, and from whom you get it? When you go through B. So this is like that. And similarly, if you do for D, 2 plus 7, 9, and 1 plus 0 is 1. So it is better you go through D. From A to D, this will be like A to D and D to D. So 1 plus 0 is 1. So you will reach it. So this is going to done by every node. A will do it, B will do it, C will do it, and D will do it. Now once they do it, now it will be the shortest distance consisting one node. But a shortest path with n node will not going to make more than n minus 1 edges. With n node, if you wanted to find the shortest part between two nodes, then it will not consist more than n minus 1 edges. If it is consist more than n minus 1 edges, it means it has cycle. So it will not going to consist more than n minus 1 edges. So you have done this procedure one time. Now you need to do it 2 times, 3 times. N minus 1 time you need to do this procedure. What procedure? You need to send your distance vector to your neighbor, then update your table like this. Okay, like I have done for A, try to update for B, C and D. So you have to do it n minus 1 times. Here we have 4 nodes. So how many times we need to this procedure? 3 times. I have only done for 1 times. Okay. So when you do for 3 times, you will get the answer. So, but it will be huge to make this for all of the nodes, and gate is not going to ask this also. Okay. Gate is not, even if it asks to draw what will be the final distance vector, you can draw it by yourself here. For example, if I want to do for A, B, C, D, and then I know from A to A 0, it will be always there. A to B, obviously there is no other way than this. This is A, this is B, this is C, and this is D. What will be A to B? So this will gonna be 2. If it is asking, then it is very easy to draw, but it will ask you this kind of question. After one step, what will be the updated table of A? So that kind of question will be asked in GATE. So A to C, I know that 2 and 3, you can get minimum then 2 and 3. So 5 will be there and D to 1. So this will be like that. Okay. So you can get, similarly you can draw if it is asking for what will be the final this table for each node. And I don't think that they will ask this question, but they can ask the question that after one round what will be the table. Now if you see for this, there are two paths that is not used. There are two paths that is not used, and question may come like this: find the those paths which are not used. Find those paths which are not used. So how will you do it? So obviously if there is a cycle, then you can remove the maximum age in that cycle, because you have already have different way to reach it. What I am telling you like this. So here if you see that this is 11, D to C is 11, and I am saying that you will not going to use this link. How? Because there is cycle that is reaching D to C with less than 11. 7 plus 3 is 10. Okay. And also there is another one cycle, 1 plus 2 plus 3, that is 3 plus 3 6. So obviously you are not going to use the 11. Similarly D to B is 7. D to B is 7. Now I am saying that you are not going to use this because in other cycle you are getting the minimum 3. So you are not going to use this link and this link. So this way question can be framed. So now we will see link state routing. So in link state we are going to create this link state packet. What we are going to do, this is again A, B and C and D. So with local knowledge we will create the link state packet. So here A, and I will write the sequence number of the packet, time to live for the packet. It has, these two has its own advantage, that is why it is there. Now at A, if you see B and D are connected. So using local knowledge, what I write, D to, I can reach D by 1 unit and to B using 2 unit. So I have written 1 unit and 2 unit. So this packet will be created by A, similarly by D and C and B. Now they are going to flood their packet. That means that everyone flood their packet. So it will flood it here. Then B get this packet, B will pass it another way. So now in earlier we see that there is no way A get the packet from C. But here in link state routing we will get, A will get the packet from C also. So every node will flood its link state packet to all other node. Now every router will prepare the entire graph using information from all the router. So what's happened that at A, every link state packet will come. Now A will have complete knowledge what will be the path will look. So it will first draw the graph, and then on that graph it will run the single shortest path algorithm, that is Dijkstra algorithm. It can use the Dijkstra algorithm to get the answer. So, and you have learned about Dijkstra algorithm. So in algorithm topics, okay. So we are going to use the Dijkstra algorithm after making the complete graph at every router, and we get what will be the minimum. So in this way in link state routing will be happen. And if you have learned the algorithm, you have, okay, you will learn about Dijkstra algorithm, and there is Bellman-Ford algorithm. So the distance vector routing is somewhat similar to Bellman-Ford, because in Bellman-Ford after one pass we will get the shortest path using one node, and then in using 2 nodes. So like that, okay. Now we will see the difference between distance vector routing and link state routing. So in distance vector routing there is bandwidth required is less. Why it is required less? Because we are only sending the distance vector, but here we are flooding the complete table, complete link state packet. In LSR we are flooding it. So when we are flooding, lots of packet will be there, and there are chances of duplicate packet also. So it requires high bandwidth. But on earlier days what happened that we have low bandwidth. That is why we used in back days DVR. But now we have high bandwidth. That is why we are using LSR, link state routing. It is going to use the local knowledge. So after you pass one distance vector, everyone will get suppose A node will get the distance vector from B and D, and they are its neighbor. But here you get the link state packet from every node. You will get at A, you will get from B, C and D. From every node you will get. That is why it is global knowledge, here local knowledge. And it is somewhat similar to Bellman-Ford, and it is similar to Dijkstra algorithm, because after making the graph we are using Dijkstra algorithm. Obviously here traffic is less, here traffic is very high because we are flooding the packet. It converges slow. How it is converging slow? After you send distance vector to your neighbor one round, then it will complete, and you have to do it n-1 times. If there are n node, you have to do it n-1 time, but here only one time you have to do it. So that is why it converges faster, it converges slowly. It is RIP, so it is routing information protocol. It is implementing using routing information protocol, and it is implementing using OSPF protocol, that is open source path first. Don't ignore these things, they are really important. Sometimes they ask question based on this. You will see that it is just like implementing using RIP, you show this statement, but if you don't remember this, then you will not solve the question also. So see, this GATE 2014, they asked this term, and remembering, that is why you have to remember something. Okay, in computer science most of the things are logical, but for some of the thing we need to remember. So this is one where you need to remember RIP, where we used, and open source path first. So where we use open source path first and RIP. So I told you in previous slide, do you remember that? So in which way you use it? So first option is RIP uses distance vector routing and OSP uses link state routing. Which of them is correct? Whether it is correct, or OSP uses distance vector routing or RIP using link state routing. So the answer is A. Correct answer is A. RIP uses distance vector. So try to remember this. RIP and OSPF, they have asked question also, and I think 2 or 3 times they have asked question based on this. So remember this. So that's all about today. We learned about 2 routing algorithm. One is distance vector routing, another one is link state routing. So try to make your concept clear, because it is not too much mathematical thing. Here you just need to make the concept clear. Once concept is cleared, you can solve the question easily. So if your concept is not clear, read the book, okay? Because there is no better way to make your concept clear by reading the standard book, okay? Thank you.